In this lesson, we are going to talk about geometric series. In the previous lessons, we introduced geometric sequence. We said that geometric sequence is a sequence that every term is the product of the previous term by a constant which we call the common ratio. For instance, if we have a sequence like a geometric sequence like 1, and the common ratio is 2, the next one is 2 times 1 is 2, the next one is 2 times 2 is 4, the next one is 2 times 4 is 8, and so forth. In this lesson, like the previous one, we are going to try to find the formula to find the sum of the first n terms of a geometric sequence, meaning I have to find S sub n of 1 plus 2 plus 4 plus 8 plus the last term, let's call it T sub n. The first thing, we are going to find or derive the general formula for a geometric series with n terms, first term to be a and a common ratio of r. This means that I have to find S sub n, which is a, plus, now multiply by common ratio, which is AR, the second term. The third term is AR squared, plus the last term is going to be AR of exponent n minus 1. Now what I'm going to do, I'm going to multiply Sn by R. I'm going to get Rsn is equal to, now if I multiply A by R, I get AR. So I'm going to write AR here, plus. Now if I multiply AR by R, I get AR squared, plus, and the last term here, which is AR n minus 2, if I multiply by R, I get AR n minus 1, and if I multiply this term by R, I get AR exponent n. Now what I'm going to do, I'm going to subtract this sequence, this sum, from this sum. So I'm going to get S sub n minus Sn is equal to, when I subtract this from this one, I'm going to get minus a. This one cancels with this one cancels with this one is going to cancel this one, and then I get plus AR exponent n. Now if I take Sn, factor it out, I get R minus 1 is a. If I factor a out, I get R exponent n minus 1. If I divide both sides by R minus 1, I get Sn is a times R exponent n minus 1 divided by R minus 1. This is the formula to find the sum of first n terms of a geometric sequence with the first term R and common ratio R. In this example, I have to see if the following series is a geometric. To see if it's geometric, I'm going to find the common ratio here. 6 divided by 2 gives me 3, 18 divided by 6 gives me 3, and 54 divided by 18 gives me 3. So this means that this is a geometric series. The next example, 2 plus 8 minus 12 plus 16, we have to see if it's a geometric series. To do that one, I'm going to divide 8 by 2, I get 4. Negative 12 by 8 is going to give me negative 1.5. And negative 16 plus 16 over negative 12 is going to give me negative 1.3. Since the common ratio is not the same, then we can say that this is not a geometric series. The next example requires of us to determine the sum of the first 10 terms. We know that a, the first term, is 20, r is equal to negative 3, and n is equal to 10. We use the general formula which says that s sub n of a geometric series is a times r exponent n minus 1 divided by r minus 1. A is 20, r is negative 3 exponent 10 minus 1 divided by r is negative 3 minus 1. If you use our calculator, this becomes negative 295,240. Negative 295,240. The next example, the sum of the first 10 terms. If the first term is 5 and r is 4, again, and n is 10, we use the formula s sub n is equal to a times r exponent n minus 1 divided by r minus 1, which is 5 times r is 4, so 4 exponent 10 minus 1 divided by r is 4 minus 1. If we simplify this one, we get 1747625. The next example, we have to find the sum of 32 plus 16 plus 8 up to the last term, which is 1 over 8. We know that the first term is 32, r is 16 divided by 32, which is 1 over 2, and we know that t sub n is 1 over 8. But we need the number of terms. So we use the formula that t sub n is equal to a r exponent n minus 1. Since a is 32, and r is 1 over 2 exponent n minus 1, we have to solve this equation. Now 1 over 8 can be written as 2 exponent negative 3. So what we are going to do is that we are going to divide both sides by 32. So it's going to be 1 over 2 exponent n minus 1 is 2 exponent negative 3 divided by 2 exponent 5. 2 exponent 5 is 32. Now this one is the same as negative 3 minus 5, which is 2 exponent minus 8. Now 1 over 2 exponent n minus 1 can be written as 2 exponent negative 1 exponent n minus 1, which is 2 exponent negative n plus 1. You multiply the exponents. Now since we have an equality between two powers with the same base, it means that the exponents, they have to be equal. So negative n plus 1 has to be equal to negative 8. I move negative n to the right and negative 8 to the left. I get n is 1 plus 8, which is going to be 9. So now we know how many terms we are dealing with. We know what is the first term and we know what is r, so I can use s of n, which is equal to a times r exponent n minus 1 divided by r minus 1, which is a is 32 times r is 1 over 2 exponent n, which is 9 minus 1 divided by r is 1 over 2 minus 1. Now if you use your calculator and simplify this one, we are going to find that this one is equal to 511 over 8. So the sum of the terms here are going to end up to be 511 over 8. The next one, we have to find the sum of the series 1 minus 3 plus 9 minus up to negative 243. Now, when you look at these series, you can see that negative 3 divided by 1 is negative 3. 9 divided by negative 3 gives you negative 3. So this is a geometric series. Now we know that A is 1 and R is equal to negative 3. But again, we don't know how many terms we have. So I'm going to use T sub n is A R exponent n minus 1. We know that negative 243 is the last term, so is equal to A, which is 1, times R, which is negative 3 exponent n minus 1. But 243 can be written as negative 3 exponent 5. Since in the equal sign the bases are the same, then it means the exponents, they have to be the same. So n minus 1 has to be equal to 5. From here I get n is equal to 6. Now knowing n, a, and r, I can use the formula s sub n is a r exponent n minus 1 divided by r minus 1. So from here I will find that s sub 6 is equal to a is 1 times r is negative 3 exponent n, which is 6 minus 1, divided by r minus 1, which is negative 3 minus 1. If we simplify this one, we get 728 in the numerator divided by negative 4, and this one is going to give us negative 182. In the next example, we have a tennis tournament that has 128 players. The regulation is that when a player loses a game, he or she is going to be dropped from the competition. And winning player is going to go on to another match, to the next round. The question is that how many in total is the number of matches that will be played in this tournament. We know that the first round there is going to be 64, which is 128 divided by 2 games, which is 64 games. Remember, 2 players they play and 1 goes to the next round. 128 divided by 2 is 64. So there is going to be 64 games. Now the next round, so this is 64. The next round is going to be 32 games, which is going to be 64 divided by 2. Now is going to be 16, and it continues until there is only one match, which is a final match. Now what we have to do is that we have to find the sum of this series. First of all, we know that this is a geometric series because 32 divided by 64 gives us 1 over 2, which is the same as 16 over 32, and so forth. So this is geometric. Now we don't know, first of all, how many terms we have here. To find that one, we know that the last term is 1. So we are going to say T sub n is a r exponent n minus 1. So 1 is equal to, we know the first term is 64 times r is 1 over 2 exponent n minus 1. From here, dividing by 64, I get 1 over 2 n minus 1 is 1 over 64. But we know that 1 over 64 can be written as 1 over 2 exponent 6. Since this equality, the basis, which is 1 over 2, is the same, this means that the exponents, they have to be the same. So n minus 1 has to be equal to 6, so n is equal to 7. So this means that we have 7 terms here. The first term is 64 and r is 1 over 2, so I can use s sub n, which is a times r exponent n minus 1 divided by r minus 1. So s of 7 is the first term, which is 64 times r, which is 0.5, exponent n is 7, minus 1 divided by r, which is 0.5 minus 1. If you simplify this one, you get that this one is equal to 127 games, the total number of games which is played.